Here are some clips of us making our first slime. Here you can see when we pull the slime apart quickly, it shears along a vertical line in a relatively clean cut. When we pulled the slime apart slowly, it stretched and thinned out in the middle while gravity pulled it down. When we hold the slime with one hand and let gravity stretch it, it stretches and thins the most at the midpoint. This is an example of creep by constant stress applied to the slime. The slime is held at a fixed distance apart and the force required to keep it stretched decreases. This is an example of stress relaxation. Next, we made the thicker bouncy ball recipe, which we unfortunately did not get on video. But we added more borax and rolled it around more to help the slime dry and firm up more. The change in recipe changed the polymer structure because adding more borax increased the number of crosslinks between the glue polyvinyl alcohol chains, thus increasing the rigidity of the structure. Our bouncy ball got to about 1/4 or 1/5 of the drop height, which was much higher than our first slime. Here is our original slime and bouncy ball slime rolled up in balls on the table. You can see that the original slime relaxes significantly faster. The bouncy ball slime has a higher Deborah number since it is more solid-like than the original slime, and since liquids are closer to zero and solids increase towards infinity. Also, using the equation, the slimes were observed for the same amount of time and the firmer took longer to relax.